If the universe is packed with stars, and a lot of those stars have planets, and some of those planets should be old enough for life to get a serious head start, then here's the weird question. Where is everybody? Not where are the tiny microbes, not where are the distant radio whispers. I mean, where are the obvious aliens, the city lights on other worlds, the giant star-powered machines, the visitors, the probes, the unmistakable sign that we're not the only minds looking up and wondering. Because on paper, the galaxy should not feel this empty. Our Milky Way has hundreds of billions of stars. We now know planets are normal, not rare. Some stars have rocky planets sitting in the zone where liquid water could exist. And the galaxy is old. Really old. Our solar system is about 4.6 billion years old, but the Milky Way is more than twice that age. That means some civilizations, if they exist, could have had millions or even billions of years to spread, build, explore, and make themselves noticeable. So why aren't aliens here yet? This is the heart of the Fermi Paradox. It's not one paradox so much as a pile of uncomfortable possibilities. Maybe life is rare, maybe intelligence is rare, maybe technology doesn't last, maybe space is just too huge, maybe they're out there, but we're looking in the wrong way, or maybe the answer is something stranger than any of that. Let's start with the boring answer, because the boring answer is secretly terrifying. Space is big. You already know that, but it's hard to feel it. The nearest star system to Earth is Alpha Centauri, about 4.3 light-years away. Light itself takes more than 4 years to get there. A spacecraft moving at the speed of the fastest human-made objects would take tens of thousands of years to make that trip. Now scale that up. The Milky Way is about 100,000 light-years across. Even if an alien civilization could travel at 1% the speed of light, which is wildly faster than our current crewed spacecraft, crossing the galaxy would take around 10 million years. That's a long time for any project, any empire, any living culture. But here's the twist. 10 million years is actually short compared with the age of the galaxy. If a civilization started exploring 1 billion years ago and had the ability to build self-replicating probes, machines that visit star systems and make copies of themselves using local materials, they might spread through the entire galaxy on cosmic timescales. They don't need warp drives, they just need patience and automation. So distance slows aliens down, but it doesn't fully solve the mystery. The galaxy has had time. That brings us to possibility 1. Maybe life itself is much rarer than it looks. Earth makes life seem easy, because as far as we can tell, life appeared pretty early in our planet's history. Once Earth cooled down and had stable oceans, biology seems to have gotten started surprisingly quickly. That sounds encouraging. Maybe give a rocky planet water and chemistry, and life just pops up. But we've got a sample size of 1. That's the problem. Earth isn't evidence that life is common. Earth is evidence that life happened here. We don't know if that first step, non-living chemistry becoming living cells, is easy or brutally unlikely. Maybe the universe is full of habitable-looking planets where nothing ever wakes up. Warm oceans, minerals, lightning, hydrothermal vents, all the ingredients sitting there like a kitchen full of food that never becomes a meal. Or maybe simple life is common, but complex life is the hard part. For most of Earth's history, life was microscopic. Single-celled organisms ruled for billions of years. Animals, plants, brains, eyes, bones, language, tools, all of that is recent. If Earth's timeline were a 24-hour day, complex animals show up late in the evening, and humans appear in the final seconds. So maybe the galaxy is crawling with slime, but almost nobody builds telescopes. That leads to possibility 2. Intelligence might be a weird accident. We like to imagine evolution as a ladder, with bacteria at the bottom and spaceships at the top. But evolution doesn't aim for technology. It aims for survival, and only in the loosest possible sense. A shark doesn't need calculus. A tree doesn't need radio. A bacterium doesn't need poetry. On Earth, high intelligence showed up in many forms, like dolphins, corvids, elephants, octopuses, apes. But technological civilization required a weird combo. Big brains, social learning, long childhoods, hands or hand-like tools, fire, stable climate, language, agriculture, metals, and a planet where energy sources were accessible. Octopuses are brilliant, but they live underwater and don't have fire. Dolphins are smart, but they don't smelt ore. A planet could be full of clever creatures that never get past clever creature. So maybe minds are common, but tool-building spacefaring minds are rare. Then there's possibility 3. Civilizations don't overlap. This one is easy to miss. The universe is old, but civilizations might be brief. Humans have had radio technology for a little over a century. That's nothing. If alien civilizations broadcast loudly for 500 years and then switch to quieter tech, collapse, change priorities, or disappear, the galaxy could be full of civilizations that miss each other in time. Imagine 2 people standing in a stadium at night, each turning on a flashlight for 1 second, but they're doing it hours apart. The stadium isn't empty. It just looks empty from where each person stands. We also assume advanced civilizations would want to be loud, but our own technology is becoming less leaky. We use fiber optics, focused transmissions, satellites with tight beams, and digital signals that don't scream into space the way early radio did. An advanced society might be almost invisible unless it's deliberately trying to get noticed, and maybe deliberate contact is exactly what they avoid. Possibility 4. They're quiet on purpose. If you discover you're in a dark forest, do you shout your address? That's the dark forest idea. Civilizations might stay silent because they don't know who else is listening. Even if most civilizations are peaceful, the risk of one dangerous neighbor might be enough to make silence the safest strategy. In space, you can't easily tell intent from a signal. A message that says hello also says we're here. Now, that doesn't mean the galaxy is full of hunters. It just means silence can be rational when the stakes are unknown and the distances are huge. By the time you learn whether someone is friendly, it might be way too late to undo the information you gave away. Of course, that raises a question. If everybody is hiding, why haven't we seen accidental signs? Waste heat, weird star dimming, giant structures, industrial pollution in exoplanet atmospheres. Maybe because our search is still tiny. Possibility 5, we're looking through a keyhole and calling the house empty. The search for extraterrestrial intelligence has barely begun compared with the size of the problem. We've listened to some frequencies around some stars for limited windows of time. That's like dipping a cup into the ocean, not finding a fish in the cup, and announcing that fish are probably fake. Alien technology might not use radio. It might communicate with lasers, neutrinos, gravitational waves, quantum systems we don't understand, or something that doesn't look like communication to us at all. Even if they do use radio, they might not be broadcasting at the right time, in the right direction, on the right frequency, with the right signal structure for us to notice. And our assumptions might be laughably human. We look for versions of ourselves, planets like Earth, water like Earth's, chemistry like Earth's, technology that leaks like ours. That's reasonable because you start with what you know, but it also means we could be surrounded by weirdness and missing it because it doesn't fit our search template. Possibility 6 is the one people call the Great Filter. The Great Filter is the idea that somewhere between dead matter and galaxy-spanning civilization, there's a step that's extremely hard to pass. Maybe it's the origin of life. Maybe it's complex cells. Maybe it's intelligence. Maybe it's surviving your own technology. And here's the scary part. We don't know whether the filter is behind us or ahead of us. If the hard steps are behind us, that's good news. Maybe Earth got insanely lucky early on, and we're rare because we've already passed the biggest obstacles. But if simple life is common, and complex life is common, and intelligence is common, then the silence starts to suggest something grim. Maybe technological civilizations usually destroy themselves or stall out before they spread. Nuclear war, engineered pandemics, runaway ecological damage, unaligned artificial intelligence, asteroid impacts, social collapse, resource traps, take your pick. The point isn't that one of these definitely ends everyone. The point is that a civilization only has to fail permanently once. But the Great Filter can also be less dramatic. Maybe advanced societies don't die. Maybe they just stop expanding. Possibility 7. Aliens don't care about being here. Science fiction trains us to assume expansion is natural. Find a frontier, go there, plant a flag. But that's a human story, shaped by human history. An older civilization might build inward instead of outward. Maybe they live in ultra-efficient habitats around their own star. Maybe they upload into simulations. Maybe they focus on art, computation, philosophy, or experiences we can't imagine. Maybe sending fragile bodies across interstellar space looks to them like crossing an ocean in a paper cup. Even colonization might not be appealing. Stars are far apart. Planets are hostile. Messages are slow. Maintaining a galactic civilization could be more trouble than it's worth. If you can create everything you want locally, why spend millennia pushing into the dark? There's also a planet-level version of this. Maybe many habitable worlds or ocean worlds covered completely in water. Life could thrive there, but with no dry land, no easy fire, no metallurgy, and no view of the stars through thick ice or deep ocean. A universe full of living oceans might still be a universe with very few radio towers. So where does that leave us? The honest answer is, we don't know. And that's what makes the question so powerful. The silence could mean we're rare. It could mean we're early. It could mean we're using the wrong instruments. It could mean everybody is quiet. It could mean civilizations don't last. Or it could mean the galaxy is alive with things we've barely learned how to recognize. But here's the part I find most interesting. The Fermi Paradox isn't just a question about aliens. It's a mirror held up to us. When we ask why they aren't here yet, we're also asking what kind of future is possible for intelligence. Can a civilization grow powerful without destroying itself? Can it stay curious for thousands of years? Can it become wise before it becomes dangerous? Can it survive long enough to be noticed? Right now, Earth is one tiny world sending out a faint glow. We've only just started listening. We've only just started finding planets around other stars. We've only just started asking these questions with real data instead of pure imagination. Maybe one day we find a signal and everything changes in a minute. Maybe we discover simple life under the ice of Europa or in the clouds of another world, and the odds shift. Maybe future telescopes spot oxygen, methane, city lights, or something stranger in a distant atmosphere. Or maybe we keep hearing silence, and that silence becomes one of the most important facts humanity has ever learned. Either way, the answer matters. Because if we're alone, or even just very rare, then consciousness is more precious than we thought. This little blue planet isn't just one noisy rock among many. It might be one of the few places where the universe has learned to look back at itself. And if we're not alone, then the silence isn't an ending. It's the opening note of the biggest discovery story there is. So why aren't aliens here yet? Maybe because space is huge, maybe because life is hard, maybe because timing is cruel, maybe because everyone is hiding, maybe because we've barely begun to look, or maybe they're not here yet because it's our turn to become the kind of civilization someone else might one day wonder about. If this made the universe feel bigger and weirder, that's the point. Subscribe for more questions that sound simple until they start rearranging your brain.